Hey, there I am. Let me just see if I'm in focus. No, I'm not. Am I now in focus? Yes, I am. Cool. Okay. So, yeah, guys, this is WebDev Sumos, and today we are going to solve 746 minimum cost climbing stairs. So, today I should probably stop saying so multiple times. And today I was solving climb stairs, which is one of the first question from the 1D dynamic programming list from leetcode. So I was able to solve it like using four methodologies. One was time exceeding, then I memoized it, then I used an array tabulated method, then I used uh, two variable approach. So I felt good about this question. So okay, again I said so. And now we'll try minimum cost climbing stairs. And yeah, let's do it. Let's turn on the timer and let's try to. Oh, I guess there was a timer turned on somewhere else. So the question says you're given array cost where cost of I is the cost of ith step on a staircase. Once you pay the cost, you can either climb one or two steps. You can either start from the step with index 0 or the step with index 1. Return the minimum cost to reach the top of the floor. So for this one, what I'll do is, as I did it in the earlier climb stairs also. So in Fibonacci, if you remember, what we do is they have given us n, and recursively we do n minus 1 plus n minus 2 and keep on sorry n minus 1, is this the factorial that I'm doing, or it's into, right, or whatever it is. Yeah, n minus 1, n minus 2, that's what we do until we reach a base case. So in this, the base case would be reaching the last stair, right? That would be our base case in this case. So what we'll do is we'll start with the highest step, like the last step, and we'll try to go down. So that would be top down approach, isn't it, or is it so yeah, so we'll, whatever approach is that, please let me know in the comment box. But what I'll try to do is I'll try to go from right to left, so that, yeah. And today I was, all the time I was in the pram interview saying my right was left, so that was really, it might be really confusing for the interview viewer. Yeah, so how are we going to do it? We will need our trusty Miro board. Yeah, we'll be needing that as well. For this one, let me type it out in, not in this, yeah, this guy, Miro board. Okay, lots of stuff I've written down on the Miro board. Okay, so what I'll do is I'll just get rid of this. So it does take time for Miraboard to load, if you know. So allow allow the Miraboard to take its time. Thank you. So Miraboard is on, and we'll take our first example, that is 10, 15 and 20. So we have this with us. Let's bring it back in middle, and what we'll do is uh, so our base case, just I'm brainstorming here, our base case would be if, so our index 0 1 2 will be starting with the 2, so we have to come down till 0th stair, right? Till 0th stair we have to, yeah. So till what point I need to calculate it, and from what point I need to start sending back whatever the cost that I calculated. Okay, so that is what I am looking for here. um, okay, so if I, so the first stair that I'll be climbing would be the 0th one, right? um, or either I can start from 15 or 10, isn't that right? So yeah, that's what we'll do. Our base case should be, if I reach either 15, either staircase 1 or staircase 0, I need to start returning from that point of time. um, so yeah, if my I is less than equal to 0, then I should return in that case the cost, whatever the cost of 0 is there. And if my I is equal to 1, then I should be returning cost of 1. So that's what I'm thinking. And basically what I want to do is minimum, I need to find minimum cost, right? So it would be minimum of whether I minus 1 n minus 1 plus comma n minus 2. So yeah, this would be our our way to going through uh, all the staircase costs. So starting from, will take the length of this guy, and that is 3. So what we'll do is 3 minus 1 is 2, and this so from 3 we'll go to 2 and we'll go to 1, then from 2 we'll go to 1 and we'll go to 0th index. So what we'll get here is, let me take yellow color. I'll at 1 I'll get 15, that's what we'll be returning here. At 0 I'll be getting 10, that's what I'll be getting here. But we are forgetting that we need to also, whatever minimum will find, we also need to add it um, to the current one, right? So minimum of whatever n that we have, cost of n, we have to add it to that as well, isn't it? Yeah, but on the index 3 we don't have anything for now. So how we will manage it, like Okay, so what should be our strategy in that case? Mm-hmm. So let me think. Can we start from 2, the index 2? Whatever the minimum would be, I guess we need to add that if cost of n is there, what we can do is, um, if cost of n is not there, then we can have 0 instead of that. But yeah, let's let us not bother about that for now. So here we returned 10, and here we returned 15, so we returned 10 from here and we returned 15 from here. So which one is smaller? So 10 is looks like 10 is smaller. Okay, but I guess instead of uh, doing the addition here, I guess I should be doing addition inside the minimum one, cost of n plus cost of n, right? So 15 plus whatever is at 2 is, let's say, uh, 15 35, right? Yeah, 35. And 10 plus 20 is 30, so 30 is smaller. And we send out 30 here, and from 1, so this guy is 1, right? So as soon as we reach 1, we'll be returning 15. So we return 15. 15 plus 0 plus 0, that won't be anything, and the 15 would be our answer. So whatever minimum is there, we'll be returning that. Isn't that it? Yeah. So let's try to write a quick short algorithm, and we can then specify its complexity later on. So what should I call it? What should I call this one? Let's So whatever it is, we'll call climb stair helper is equal to what does it take is, it takes in the index. Okay, it takes in 3, or let index is equal to cost dot length plus so the length is 3, so we'll start with 3, and we'll be returning the minimum cost that we'll find. So yeah, that's what we are going to do. And let's go here, climb stair helper, let's call helper 3, sorry, index, or let's call it n instead of index, n, and here we'll call it index. Okay, if our if index is less than equal to 0, then we will return cost of 0, and if index is equal to 1, then we will return cost of 1. Okay, so that is what our base case is. Then what we need to find is, if so just for that guy I need to somehow change this But how can I change that around? If I send n minus 1, let's say if I send n minus 1, which is 2, which is 2, so what I need to do is math dot min climb stair helper. I need to send index minus 1, and I also need to send climb stair helper index minus 2, and then I can confidently write cost of index, whatever the current index that we are on. We can simply add it to this guys, and whatever the minimum is, we can start. Oh, sorry. We can confidently send that upstairs. Let me zoom the So if I have this, and if whatever I've done is right, okay, this is returning 30 when it should have returned okay, less than equal to, if my index is equal to 1. So what should we do in this case? Should we also send the current cost, which will be zero in this case? Sorry, so the cost will be cost, and while we are sending this, we will send 0, and to the next guy we'll be sending cost of index, cost of index. That's what we can do. And then if we run this why didn't this work? Oh, sorry. I should write cost and cost of index, but I am forgetting that there is no index available here. So how will I get the current index that I am right now on? Let's do one thing. I don't need to do this. What I'm thinking to do is that I'll just check if index is greater than cost dot length, or greater than or equal to cost dot length, then let cost is equal to 0. If it is greater, then what I'll do is, if index is less than cost dot length, then cost is equal to cost of index, then I can comfortably say that my cost will be this. Let's say price, 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 right? Yeah, now this works. um, but but there is a catch. If somehow I try to run this is going to time out because we are doing it for 2 raised to n, and we need to memoize it. So how will we memoize it? If we go to our board, let's go to our board, and so this is a pretty small example. So if you see here, um, like I can just point out a simple example. If you see one, oh, the Miro board is out of sync. Looks like, yeah. If you see um, this one, so this one and this one are getting repeated. So whenever the one comes, so and for this example, it is just this one, but imagine there is a big tree and there might be multiple indexes that might be getting repeated, and so to avoid that repetition, we need to memorize that. And for memorizing that, what we'll do is, what is the best approach of doing that would be, um, we will let's call it memo. We'll memorize it using whatever the value that will come out from here at that index. That will be surely the smallest value. So for that index we can memorize this value and return that value ahead. And for this we can again add, oh sorry, I used memo, right? So if index in memo, if we have already seen that, if we have already processed that, then we can simply return that index. If we run this now, this works, and if I run this should work. Okay, so what we did is, from 2 raised to n, we brought that down to complexity n, right? And the space complexity would be also n of this. Okay, so from doing this, the next step will be, how can we make sure that our costs, how can we make this into a tabulated form? So that is the next step that we can go from here. So if you see here, our cost 0 and cost 1 remains 0, like or as is, like what do you say, if we reach on that particular, the cost at 0th index will be cost 0, and the cost of starting from 1 will be cost of 1. That won't change. For example, 10 will remain as is, 15 will remain as is. Okay, so the only way to find out what will be the cost of getting to the last one would be to just see, if I go here and I can climb two stairs from here, right? That is, I can take 15 and then I can go here, or I can just 10 and 20 I can go there, or I can just from 15 I can take two steps. That should do it, right? So my intuition is saying that we'll be needing n plus 1 array, n plus array of n plus 1, and yeah. So let's go to the Miro board, and let's say if we can, just take this guy, take a screenshot of this guy, and which will help us to compare whatever is going on. Let's copy this. And I'll try to paste it here. Okay, so that we can refer this. Hopefully this guy is visible, and once we do that, what we can do is we can start thinking in terms of our tabulated form. So that would be helpful to make this into a tabulated answer. So what was our input? Our input was 10, 15 and 20. Okay, let's use our usual colors. Okay, 0, 1, 2. It was 10, 15, 20. And what we can do here is that my idea was to create a tabulated form, because we want to go to this, right? A step ahead, like the last step would be this one. Let me draw all the steps. So 0, 1, 2, 3. So we start, if you have seen the last step that we did in the recursion, we started from 3, then we go to 2 and 1, then from 1, 1 and 0, and yeah, that's what we did. So similarly we have to reach to 3, starting from this guy. So yeah, so what we'll do is we'll make our these values, whatever these are, so 10 and 15. And what we need to do is we need to find what will be the minimum cost to get to step 2 from both of these elements. Okay, so for step 2, what I'll see is I'll add what we were doing in this case is, whatever our current price is, we were kind of checking it with index -1 and index -2. So we'll be starting from 2. So 2 will check if I add whatever is on index 2 with whatever was on one step minus the current step, or 2 steps, which will be this guy. So whatever the minimum is, that will I'll put onto the 2. So what is that? I'll see that 20 plus 30, and I'll get 20 plus, so the candidates would be 30 and other candidate would be 35. So obviously I'll take the minimum of these two. So if you're wondering how 30 and 20 came, so 20, sorry, let me just start my camera back. It didn't turn on. Okay, now it's back. So 20 plus 10, 20 plus 10 would be two steps, two step count, and one step would be 15 plus 20. Okay, so that's how we got 30, and that's how I got 35. So what is minimum out of this two is 30. So now that we reach the step third, we can check whichever is minimum out of the last two steps, which would be 30 plus 15, and as there is no cost of taking the step, where that will be 0. So 30 of 15 is minimum, so we'll take 15 happily, and we'll just return this answer. Okay, so let's see if this code will work out. Yeah, hopefully this all is making sense, but yeah. Okay, so what we'll do is we'll get rid of this, and what we'll do is let dp, let's call the array dp as we normally do. We all do it. N plus 1 should be the array size. Yeah, and what we'll do is dp of 0 would be cost of 0, that is obvious, and dp of 1 is cost of 1, that is also obvious. And what we'll try to do is, for let I is equal to 2, we'll start from 2, I is less than equal to dp dot length, okay, and I plus plus. So for yeah, and for this we have to also make sure whatever the price is, current price, if we have to only make sure, like in the last one, we were just checking if we are at the last index of the dp, then we want to make our current price to 0. Otherwise we'll always have a price that we can take from the cost that is given to us. Yeah, so that's what we are going to do. If I is equal to dp dot length minus 1, then what we'll do is let's make it a ternary operator. If that is the case, then we'll put 0, or else cost of I, whatever the I we are on, we'll keep that as is, and then dp, yeah, and dp of I we have to set, right? So dp of I would be dp of I minus 1, which is step 1, plus current price, that's what we did, right? And comma dp of I minus 2 plus current price. So we'll just make sure that we are encapsulating it in math.min. Okay, yeah, we are encapsulating it in the math.min, and whatever minimum that we'll get, we'll assign it to dp of I, and return it. Okay, and return dp of n plus 1, right? N plus 1, and here yeah, n plus 1, basically we can return it 0 1 2 3, or not n plus 1 bus, and just n, because n would be pointing at the index 3, in this case 0, 1, 2 and 3, so 3. Yeah, that will that work? Have I done something? Why is it so slow? Or is it my internet connection? Or is it timing out? Really? What's the issue here? Okay, yeah, it got accepted, but what was with the with so much time? Okay, yeah, so this worked, but I'm not entirely sure, like whatever I'm doing at step 13th, how should I actually watch out for what I'm doing at 13? So that's the only concern. But now, can we just get rid of the extra space that we are using? Because every time we are just using two values, right? So how can we do that? So let's go back to our Miro board and let's see what two values are we considering every time. So if we get rid of everything here, what two values we were having 10 and 15, right? We were always holding them. So let's say my step 1 count would be 10 and my step 2 count would be 15. Okay, and when I'm checking, um, so we are always checking backwards, right? So I'll call my step 1 as step 2 and step 2 as step 1, right? So from 2's perspective, if you see, uh, step 1 would be, if we come one step down, then we'll be pointing at 15, and if we come 2 steps down, then we'll be pointing at 10, right? So yeah, that's why um, I ke- I'm I'm indicating it that way. So let's see, if I'm on 20, then what I'll do is I need to basically calculate the amount, right? Whatever the price will be. Uh, so I need to take the current price, whatever the current price I was having, I need to take that. Okay, I took that, which is 20 in this case, and what I do is, okay, so um, yeah, what I'll do is I must when I'll go to step 3, the only two steps, two prices that I'll be requiring would be 1 and 20. So we have to forget about the step 2 value. So yeah, whatever the minimum would be, I'll assign it to step 1 and then step 2. So in order to do that, what I'll do is I'll store temp step 1. I'll store it in this value, so 15 I'll store here. Then I'll calculate whichever is the smallest, 20 plus 10, 20 plus 15, which is 30, this is 35. So I'll assign step 1 as the minimum and step 2 as temp. Oh, sorry guys. Yeah, temp 2 as temp step 1, right? So so our array would look like 30, um, yeah. So we and if you see that yeah, we won't be having an array. If you see in the in perspective of array, is that now we don't need this anymore. We just need the last two values. So in the step 1 and step 2 case, step 2 will become 15 and step 1 will become 30 for step 3. isn't that isn't that the case? So hopefully that made some sense. But yeah, I guess that's what we need to do. Instead of now, what we'll do is, instead of creating a dp array, um, we will just create let stair um, stair 2, let's call it stair 2, and let's call it stair 1. Okay, or down step 1 and down step 2 should be a good name, right? Because we are stepping down, stepping down 2, stepping down 1. Oh yeah, stepping down should be a nice name. Stepping down 2, stepping down 1. Okay, so that will be there from 2. Always remember to imagine it from the perspective of 2. um, so yeah, n plus 1, we have to go till n plus 1. And if our dp is equal to n, then at that point we have to make our current price this. And always remember that we have to also store the value of the the first the second one, right? The stepping stepping down 1, temp stepping down 1, we should store it, because that is what going to be replaced with the new value, right? As we discussed earlier. So it might be confusing a bit, but yeah, stepping down 1 and here stepping down 2. Okay, so we got our current prices, and then once the stepping down of 1 has been assigned, then we want our stepping down 2 to point at temp stepping down 1. Yeah, I guess yeah, that should be it. And finally our answer should be in stepping down 1, right? Yeah, our answer should be in stepping down 1. I hope so, it's in there. Yeah, okay, so that's perfect. So what we did today was, we saw four variations of this. First, we memoized it. First, we saw a timed out version of the algorithm, which was 2 raised to n, I believe, where n was the number of costs that we have to travel through, and that the space complexity was so let's go back on the Miro board to just see what we did today. So we did so the first I'll just say time exceeded TE. Okay, it again. Really? Okay, let me just refresh it, and then it can come back and we can work on it. Okay, so it's back online, and let's call it let's what the hell, yeah, TE for time limit exceeded, uh, that we were doing it for 2 raised to n, and the space big O of 2 raised to n, and space complexity was n for that, where n was the cost, so that will be the height. And then memo version was n, and the space complexity was also n, and the dp was iterative one, which was still of n, and the space complexity was of n for this one. And uh, the the other one, in which dp where we got the space optimize, will say of n time complexity, and space complexity was of 1, because we got rid of the uh, what do you say, the array, right, in which we were keeping the tabulation. So yeah, I would definitely recommend that first solve climbing stairs, and then come on to the minimum cost climbing stairs. So yeah, that would be really helpful. And if you guys like this one, if you guys like this video, then please leave a like, and if you want to subscribe, then you can. Thank you so much, guys, for watching. Hopefully that was helpful, and I'll see you in the next one. Thank you. Bye bye.